liftoff of the Space Shuttle Discovery with the Hubble Space Telescope.
Capcom, we have a go for release.
It may be the boldest experiment ever undertaken in astronomy, with a legacy that will endure for centuries.
You have been awarded the Nobel Prize in Physics.
The Hubble Space Telescope is probably the most scientifically productive instrument in history.
This single tool, the Hubble Space Telescope, has revealed the size and age of the universe, the birthplace of stars, and the existence of black holes. It's helped us find planets like our own in far-off solar systems, and a mysterious force, dark energy, that makes up about 70% of the universe.
The Hubble Space Telescope has completely changed the way that we as scientists understand the universe.
The story of Hubble is a story of discovery. It's also the story of one of the biggest blunders in the history of science.
This is the moment we find out that we are doomed to failure.
Is it possible that you could bring the telescope back?
And of the genius and courage that saved the day.
The moment of truth is coming. You can't run from it anymore. It's coming. There it is.
Now, on Hubble's 25th anniversary, NOVA tells the remarkable tale of how this magnificent machine was built, how it has solved some of our most enduring mysteries, and how it is showing us a universe as beautiful as it is astonishing. Invisible Universe Revealed, right now on NOVA. Since the dawn of humanity, we've looked to the heavens and wondered, how old is the universe? How many stars are there in the sky? Are there other planets out there like our own? But in the last 25 years, there's been a revolution. All because of a machine called Hubble. Traveling in space, high above the distortions of our atmosphere, gives this giant telescope great power.
It's the size of a school bus. It's traveling at 17,000 miles an hour. It's 300 and something miles above your head. But in there is one of the most precise mirrors mankind has ever built.
Billions of times more sensitive than our own eyes, the space telescope has literally brought the universe to us, making more than 1 million observations. One legendary image is called the Pillars of Creation. It's a giant plume of gas and dust where stars are born. Our own sun probably formed in a place like this.
The whole region is something like 400 trillion miles. So it's massive, it's huge. But still within the context of our own Milky Way, it's just one little part.
Hubble has also captured pictures of places where stars die. These are planetary nebulae, remnants of expiring stars.
They look like artworks in the heavens. Each one of them is different, like snowflakes. And these are some of the most spectacular images that Hubble has produced.
Hubble has shown us that black holes are real. A giant one sits at the center of our galaxy, and nearly every other we know. It's discovered the age of the universe, and that there are more stars in the heavens than grains of sand on all the beaches and deserts of the world combined. Over the past 25 years, Hubble has told us a story of creation, destruction, and of vast new mysteries that beckon our curiosity. But putting it in space long seemed an impossible dream, even to those who took on the challenge.
I started out in optical astronomy and spectroscopy. But as a woman in my generation, I could not get tenure at a research institution. In 1959, when NASA was formed, one of the men there asked me if I knew anyone who would like to set up a program in space astronomy. And I decided that the idea of influencing astronomy for 50 years was just more than I could resist, and so I took the job.
Astronomer Nancy Roman is known as the mother of the Hubble. She worked on its design and development for nearly 25 years.
If I brought anything to it, it was perseverance and belief that it was possible.
The idea of a space telescope was first seriously proposed in 1946 by Princeton scientist Lyman Spitzer. He was the scientific visionary, and Roman was the force that pushed this vision forward, decades before the technology was up to the task. Even into the mid-60s, just getting a rocket safely into space was a challenge.
There were a lot of failures. We were babies learning how to walk. And we didn't always succeed. Babies fall down, and we did too.
But however far-fetched at the time, the lure of getting a telescope above the distortion of the Earth's atmosphere was strong. The major challenge facing astronomers was the twinkle of the stars.
Twinkling stars are an inspiring source of poetry, but in terms of observing stars, it's not very good.
If you can imagine you're swimming on the bottom of the swimming pool and you look up and you kind of see the distortion, just like a funhouse mirror. That's what it's like to study stars from the surface of the Earth. The atmosphere is just like that water in the pool. It sloshes around and moves and distorts the image. But when you come up out of the water, everything's clear. That's exactly what happens when a telescope gets above the atmosphere. In the pristine vacuum of space, light can travel for billions of light years, undisturbed.
The atmosphere not only distorts light, it prevents some from reaching the ground at all.
So for those reasons, astronomers for a long time were eager to get something outside. And so I got a committee together, and that was the beginning of the Hubble.
The Space Telescope was named for Edwin Hubble, the great astronomer who did much of his pioneering work in the 1920s at Mount Wilson Observatory in California. In those days, our own galaxy, the Milky Way, was considered the entirety of the universe. Nearly everyone, even Einstein, believed the universe had existed forever in its present state, that it was eternal and unchanging. But Hubble would prove them all wrong. He began by figuring out how far away the stars he was seeing actually were.
At the time of Edwin Hubble, it was hard to measure distances. It still is, even today.
It's difficult to know if a star appears bright because it is actually bright or simply because it is close to us. So Hubble searched for a rare type of star called a Cepheid variable. Cepheids pulse at a known brightness, so by measuring the amount of light he could see, he could calculate how far away the star actually was. In October 1923, Hubble found a Cepheid in a gaseous cluster of stars then called the Andromeda Nebula. It yielded a shocking discovery.
And when he actually did the calculations, he discovered Andromeda was roughly a million light years away from us, which was outside our galaxy.
Andromeda was its own galaxy.
Oh, there are other galaxies out there, and we're just one of them.
For the first time in history, there was evidence that our universe stretched far beyond the Milky Way.
But then what he did was, we measured the speed of a whole bunch of these galaxies.
Edwin Hubble measured speed by looking at the light the galaxies emitted. He knew if the galaxy was moving toward him, the waves would shorten and shift to the blue part of the spectrum. If it was moving away, the waves would lengthen and shift to the red.
Every distant galaxy Hubble looked at, he saw the light from it being redshifted, which meant everything is moving away from everything else.
And he found the further away they were, the faster they were going.
In fact, the universe itself was expanding, stretching the light from the galaxies. Edwin Hubble had changed our understanding of the cosmos forever.
The whole universe was clearly expanding. And so this was the discovery of the expansion of the universe, which Einstein said, well, that's crazy, right?
The discovery of the expansion of the universe, of course, was a very strong piece of evidence for a beginning. If everything is now expanding, you can run this backwards and see that everything should have started from a certain point or singularity, what we today call a Big Bang.
That was pretty radical and mind-blowing stuff back in the 20s and 30s, and some people today even find it mind-blowing.
Hubble's discovery opened up the modern era of astronomy and raised huge questions, like how old is the universe? But astronomers couldn't see clearly and deeply enough into the cosmos, so the mystery would endure for decades.
Determining the age of the universe was definitely one of the key goals of the launch of the Hubble Space Telescope.
Astronomers used to have fistfights where the universe was 10 billion years or 20 billion years old, until we launched the Hubble Space Telescope.
But first, they would have to build it.
I realized that my job at NASA, to a large extent, was salesmanship. And it was a particular problem with Congress.
We can cut the space program sharply. The Congress has already cut that $400 million. I think we can cut it $1 billion, and we should cut it $1 billion.
Proxmire was quite famous senator of picking out projects that he thought were stupid.
We have a war going on in Vietnam.
And he asked NASA why the American taxpayer should pay for something like the Hubble. And I came up with the answer that for the cost of a night at the movies, every American would have 15 years of exciting discovery.
Finally, after more than a decade, the plans were approved in 1977. Hubble's power would come from an 8-foot-wide mirror. It would gather light from across the universe. To magnify the sky and see tiny details, it would need a long distance to focus the light and give a clear image. But a space telescope needs to be compact, so Hubble would use a second mirror to further magnify the light and focus it onto the cameras. For it to work, the mirrors would have to be perfect.
Hubble was the most precise optical mirror ever made.
No place along its surface could it deviate from a perfect curve by more than a millionth of an inch.
An optics company, Perkin-Elmer, was chosen to do the work, in part because it had already made mirrors for spy satellites.
They told NASA, we know how to do this, and this technology is proprietary. We are not going to let you come in and watch what we are doing. So NASA got a rather limited view of what was going on in that little group.
And they had very, very precise instruments that they designed just for polishing this mirror. They had to work at night so that the vibration of cars in the parking lot wouldn't cause problems with the polishing equipment. They had to isolate it and float it on a table so any vibrations from the building wouldn't come in. And this program was over budget, behind schedule. They were desperate to get the telescope built and flown.
Perkin-Elmer's own measurement showed discrepancies in the surface of the mirror, but this was never passed on to NASA. The telescope was declared ready for launch, a disaster waiting to happen.
The hopes and dreams of the world's astronomers were with us that day at Cape Canaveral.
Go ahead.
The last time astronomers leapt a factor of 10 in observing capability was when Galileo in 1610, instead of using his eye, put the telescope in front of his eye.
And liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
All increases in capability after Galileo were incremental. They weren't leaps of a factor of 10 until Hubble.
Mission Control, Houston.
Roger, roll, Discovery.
We thought, let's go, we're off to the races. Little did we know the time bomb that was ticking. Little did we know.
Discovery, Houston. You have a go to open the doors. Roger, Houston.
After nearly 30 years of planning, on April 25, 1990, astronauts used a robotic arm to deploy the Hubble Space Telescope in orbit, 380 miles above the Earth.
Capcom, we have a go for release.
We concur, Charlie.
Mission Control Houston confirms the Hubble Space Telescope is released.
With the telescope finally in place, everyone was excited to see what it could do.
Scientists make final adjustments before we get to see the clearest pictures ever seen in the history of astronomy.
Nose gear touchdown.
But when the first images arrived, they weren't quite what the scientists had expected.
When they first saw these images, they just assumed the telescope wasn't in focus. They tried to move the focus backwards and forwards, but the light kept being blurred, like it was always out of focus. It was really quite a shock.
We were very worried.
I just couldn't believe it. It definitely was a huge shock.
We're supposed to revolutionize astronomy. How is it that we can't focus this telescope? How is this even possible?
After weeks of investigation, horrified astronomers suspected something was wrong with the mirror.
This is my logbook that I kept during the early days of Hubble. Daily, we went to meetings and we kept a record of everything that was happening. Here's a particularly interesting day. We were told about the actuators on the back of the mirror. The actuators might be able to fix small errors in the surface of the mirror by pushing and pulling on it. So this says 1/2 wave is 7 times the dynamic range, meaning the problem is 7 times worse than they could fix. And here's a little note I wrote. This is the moment we find out that we are doomed to failure.
Sandra Faber and her colleagues realized that the problem was massive and lay at the very heart of the telescope.
The Hubble telescope has a big primary mirror that collects the light. And then there's a secondary mirror which reflects the light back down to the detector. So if everything is working, every zone of the primary mirror should come to a focus at exactly the same location.
With a single focal point, a star would appear crisp and bright. But this wasn't what was happening.
As I looked at those star images, I could see that the problem with Hubble was the rays are coming to a focus at different points. And that is the classic problem called spherical aberration. This is the actual set of images that my team presented that convinced people of the spherical aberration. The top set of images is simulated with software. The bottom is the actual images. And the fact that they match is what shows that we really understood what was going on.
That was a kiss of death. It was like a bullet to the head. So I said, well, what are we going to do?
Should we declare this telescope to be junk and just end it? Can we use it in its present form and get something out of it? Can we fix it? And all of those thoughts were running through people's minds in those fateful days after this discovery.
Somehow the mirror had been polished too flat, and there might not be anything anyone could do to fix it.
It was probably early June when people started saying the S word, circle aberration. That led up to the infamous press conference that I'll never forget as long as I live.
What might have made this happen?
Do you know for sure that the aberration is in the primary mirror, the secondary mirror, both? Why wasn't it caught on the ground?
That's correct.
This was one of the most expensive science projects that NASA had ever undertaken, and it was a techno-turkey.
Is it possible that you could bring the telescope back?
It was an absolute disaster. And so it became life and death for NASA itself. It was the national joke.
We went from being the heroes of the universe to the Mr. Magoo's, and being associated with the telescope was like difficult.
A NASA board of inquiry searched for clues to what went wrong. Inspecting every piece of every tool used to polish the mirror, they found the smoking gun. A few missing chips of paint. They had thrown off the laser-guided measuring tool used to shape the mirror.
Everything was off about 1 millimeter. And so they polished the edges of the mirrors a little too flat. About 1/50th of the thickness of a human hair.
Many feared this meant Hubble was dead, since the mirror was hard to access and impossible to remove in space. Sandra Faber was on the panel tasked with finding a solution.
The Blue Ribbon Committee convened. People were thinking about everything from bringing the telescope down to having astronauts go up in orbit and swim down into the tube and install correcting optics in front of the primary mirror.
Basically shows the front end of the telescope.
I called the report jokingly 50 bad ways to fix a space telescope.
The best idea was to put small corrective mirrors in front of the cameras and other instruments. But the problem was getting the mirrors inside the telescope. Jim Crocker was an engineer in charge of Hubble operations.
We got to the point where it's like, we're kind of running out of ideas here and not sure what to do. There's a lot of ways to fix this. There's just no way to perform them in space. I actually came back from the meeting and went back to the hotel we were staying at. And I thought, well, I'll take a shower before we go out to dinner. The shower head's on a sliding rod, and the head goes up and down. And so I turned the water on, and I slid it up, and then it was like it clicked. If we packaged the mirrors into a little robotic arm, and we put that arm into a new instrument, it could raise this mirror up and flip the little mirrors out in front of each of the other instruments and correct them all. And I thought, that'll work.
NASA agreed and immediately started work. Astronauts would install an instrument called COSTAR. Once in place, its 4 arms would flip out like the showerhead and essentially give Hubble glasses. But no one had ever done anything remotely this intricate in space.
And when I got a job, I didn't smile and I didn't celebrate anything. I says, here we go. And I'll do the best I can with this. I told NASA and I told the media, they're all saying we're gonna fix it. And I told them, I don't know if we're gonna fix it.
Musgrave and a team of astronauts trained for 20 months preparing to fix Hubble.
We choreographed this dance down to every finger and every toe. You know, a great ballerina, it's every finger and every toe. You can't have something messed up. You can't exactly mimic what you're going to do there. So in your imagination, you watch yourself work. Then it is practice so that you can pull it off when you have to.
To simulate working in space, the astronauts spent 400 hours underwater, rehearsing on a mock-up of Hubble.
I think the most incredible thing about this is that the astronauts were prepared to risk their lives to go and fix a scientific instrument.
OTC CDR, how do you read this morning?
We know the shuttle was not a perfect machine. After all, there's been 2 disasters.
This is shuttle launch control list.
Out of 1 in 10 chance of dying. I don't like those odds. But it's not a matter of fear. You've decided ahead of time this is what you do in life.
And we have liftoff. Liftoff of the Space Shuttle Endeavour on an ambitious mission to service the Hubble Space Telescope.
In 8 minutes, they went from 0 to 17,500 miles an hour.
Roger roll, Endeavour.
It's rough, and the vibrations are very rough. It's a butterfly bolting on a bullet, you know, that's what's going on.
It takes the crew 2 days to catch up to the telescope.
As soon as I caught that bright star out there, it had to be Hubble, nothing else. The moment of truth is coming. You can't run from it anymore. It's coming. There it is.
Endeavour, the Keep Alive monitor is disabled, and you've got to go for capture.
The crew will do 5 spacewalks, at the time, the most ever attempted on a single mission.
Okay, visor says required.
On the 3rd walk, Musgrave and astronaut Jeffrey Hoffman need to replace Hubble's wide-field camera. It was designed to capture a broad range of light frequencies across a large area of the sky.
Look at that baby. Beautiful, spanking new with.
The most critical moment comes when Musgrave takes off the camera cover. As he removes it, he exposes the camera's delicate mirror.
Gonna count the release. Hold it down lower.
Coming off, if you touch that mirror, it's over.
One more time.
If you touch that thing, every image that comes down from Hubble got your little fingerprint on it. And that's very bad form.
Hold it down lower. No, we're doing real fine, okay?
Scheduled to take more than 4 hours, the crew pulls off the meticulous repair in half the time.
You've got about 2 feet to go. You're looking real good.
Finally, the team turns its attention to CoStar.
You're free of the rail.
Astronaut Catherine Thornton pulls out an old instrument to make room for the new corrective mirrors packed inside a huge case.
I can't see anything anymore. Your call. Keep coming up.
So you saw these massive, great sort of refrigerator-sized instruments that had to be maneuvered precisely in place.
Much daylight we got left. Not much door.
It became a real drama. And would they do it? Would they get it in?
Getting done. Completely close the doors now. Very
After 2 hours, the instrument fits exactly as planned.
We did our job. We were pretty happy with the job that we did. But even if, yes, we did the job perfect, I didn't know what the result would be.
Sit down, Chris.
Back on the ground, the room is packed as they prepare to receive the first images.
I told somebody at the time that it was almost like when your child is born. You know, you sort of think that everything is going to go right, but you really don't know.
I'll never forget it. I mean, I'll remember the birth of my 2 kids and the night we saw the first image from Hubble. We're all huddled around the screen. And I'll never forget when that screen lit up and first appeared a little dot right in the center. And that by itself was good news because there was no fuzz around it. But then more and more little dots, stars, started showing up until the whole screen was filled with crystal clear points of light. And all the faint stuff we were never seeing suddenly showed up. And we knew we had fixed Hubble.
Once we saw the new images, we knew that that's it. They nailed it.
Astronomers leaped to their feet and applauded and cheered and whistled and hooted. It was unforgettable.
It was a stunning success in the end. You know, the trouble with Hubble was over.
With the Space Telescope now fully living up to its design, scientists could finally begin to solve some of the timeless mysteries of the universe. The solutions to many of these mysteries lie in the countless beautiful images Hubble has sent back, the most detailed ever taken of the heavens.
You cannot help but be in awe when you look at Hubble images.
In addition to these images being beautiful, they help us to answer the questions that humans have been asking for forever.
Questions like, where do stars and planets come from? And this Hubble picture of the Orion Nebula gave us unprecedented insights.
This particular image is so incredibly detailed. We can see stars forming. All of this background colorful structure is hydrogen gas. When gravity starts to take hold, the hydrogen atoms come together and undergo nuclear reaction. So they start to form a star. And so a lot of what you actually see in this image, all of these bright dots, are these things. They're newborn stars.
This single image reveals 3,000 newborn stars. And it also showed astronomers something else they'd never seen before.
If you zoom in and look really close, what you can see are these very cool little protoplanetary disks. So these are tiny little solar systems that are starting to form. Our own solar system was probably in a very similar state billions of years ago. So the sun and the earth and all the planets were contained inside this disk of dust. What Hubble did was it really opened the door for us to image these disks and be able to see them with our eyes.
Hubble can see light up to 4 billion times fainter than the human eye.
It can point to the most distant galaxies in the universe and stare at them continuously without moving, while it's flying around the Earth at 17,000 miles an hour.
This has allowed astronomers to solve another enduring mystery. How many stars are there in the universe? They did it by zooming in to a tiny patch of sky.
We wanted to find out what happens if we just stare at a blank piece of sky.
About the area you would see if you looked at the sky through a drinking straw.
And so we stared at a single point in the sky, a blank point, for about 10 days.
In this seemingly empty sliver of sky, Hubble revealed 10,000 points of light.
Every point is another galaxy.
Each one of those galaxies is a collection of about 100 billion stars like the sun.
Every galaxy is made of stars, dust, and planets in solar systems like our own.
And as you fly through the whole almost 12 billion years of cosmic history, you start to see galaxies change as you go deeper and deeper in. And right at the very end, you see these really sort of orange and red, fuzzy little blobs, which are the very earliest galaxies.
In visible light, these are the deepest images of the universe.
So, in a point on the sky, no bigger than a drinking straw, there are 10,000 galaxies. So it told us instantly there were 200 billion galaxies in the observable universe. Each galaxy has roughly 100 billion stars. You do the math, and it tells us how many stars there are in our observable universe. It's 2 with 22 zeros after it. We didn't know that before the Hubble Space Telescope went up.
The telescope would also help answer another one of the most profound mysteries ever contemplated. How old is the universe?
The Hubble Space Telescope represents exploring in the true sense. You don't know what you're going to find.
The discovery of the age of the universe would take a circuitous route, building on Edwin Hubble's breakthrough that showed the universe is expanding. It would also set the stage for a shocking surprise.
Everybody had known for many years that the universe was expanding, but everybody had assumed that the universe would slow down in that expansion because gravity would attract everything to everything else, and that would slow the expansion. And the big question was, is there enough stuff in the universe to gravitationally attract the universe to come to a halt?
Is gravity retarding it enough that eventually the expansion will stop, and then the universe would start contracting? And so we wanted to measure, as far out as we could, as far back in time as we could, the past expansion rate of the universe and compare that to today.
Like Edwin Hubble had decades before, the scientists needed to find stars of known brightness so they could accurately measure distances. Hubble had used Cepheid variables, but Perlmutter and Reese searched for something called a supernova type 1A. These exploding stars all burn with the same peak brightness, 5 billion times brighter than our sun. But the trick was to find them.
They really are rare. They only explode a couple times per millennium in a given galaxy of 100 billion stars. And for that matter, they don't give you any advance warning. You don't know when it's going to happen. And then once a supernova explodes, it brightens in a few weeks and it's faded away in a few months. But if you can observe some, 50,000 galaxies in the course of a night, and then if you can wait a few weeks and come back and observe the same 50,000 galaxies, now you have a reasonably good odds that new supernova will have exploded in some of those galaxies.
The Hubble images made it possible to measure how far away the supernovae were, and how long it took their light to reach the Earth, even when they had exploded billions of years in the past.
And that's, of course, the whole game here, because you need to be able to tell the brightness of that supernova to tell exactly what point in time in history you're looking at.
With the same technique Edwin Hubble had used, redshift, Perlmutter measured a distant supernova's light to see how fast it seemed to be moving away. He expected to see that the expansion of the universe was slowing down, but he was in for a surprise.
It was 7-8 billion years back in the past, and that one supernova suggested that the universe was not slowing down. And this was very interesting, very puzzling.
His team then analyzed 42 more supernovae and came to a shocking conclusion.
That data set strongly suggested that the universe was actually speeding up.
Adam Reese was part of a competing group, and his work was yielding the same odd result. Looking into the past, he expected to see that the expansion of the universe had slowed, but 5 billion years ago, it started to accelerate.
You know, you worry a tremendous amount because there are many ways to get a measurement like that wrong. Pretty much only one way to get it right.
The two teams working on this at this point were in really tight rivalry. We were not talking to each other about what we were finding at all.
You wake up at 2 in the morning and you think, oh my God, did I account for some subtlety?
We knew that if we got anything wrong, the other group would be sure to point it out.
Did I subtract it from the total? Is this right? And, you know, this is like cosmic accounting. You know, you got to make sure that it's right.
But the numbers were correct. Within weeks of each other in 1998, the two teams announced the same shocking conclusion. The expansion of the universe was speeding up.
You have been awarded the Nobel Prize in Physics for the discovery of the accelerating expansion of the universe.
Perlmutter and Reese, together with Reese's team leader, Brian Schmidt, shared the 2011 Nobel Prize in Physics. But their discovery had opened up a whole new mystery. What was fueling the acceleration? Scientists called it dark energy.
Something like 70% of all the stuff of the universe has to be made of this dark energy for the universe to be accelerating the way it is. And so it's possibly the most important stuff in the universe, and we don't know anything about it.
I don't really know what dark energy is. We don't have an explanation that would satisfy really anybody, especially a physicist.
And so it's blowing everybody's minds again. I mean, physicists call this the most important problem in physics because we don't know where this dark energy's come from. We can't calculate where it's come from. Our models don't work.
But despite the mystery, the discovery helped finally resolve the question astronomers had dreamed of answering for centuries. How old is the universe?
You need to know that history of when was it faster, when was it slower, if you're going to piece it all together and work our way back to the point at which all the distances would go to zero, the beginning of the universe, the Big Bang.
Scientists found Cepheids and supernovae stretching far across the universe. They used Hubble to measure their distances and redshift to figure out how fast these points seemed to be traveling away. This revealed how long the total expansion had taken since the Big Bang.
Hubble provided a ruler for the universe. So when you put together the basic size and the history of how fast things were going in the past, you get 13.7 billion years.
Our universe is 13.7 billion years old. Hubble had finally helped answer this fundamental question.
There was a promise, and Hubble delivered on that promise.
And then, nearly a century after Edwin Hubble first glimpsed galaxies beyond our own, the Space Telescope took on another profound question. How do galaxies actually form? At the center of the mystery, black holes. Regions so dense that nothing can escape their pull.
The basic idea of a black hole is the gravity is so strong that nothing can escape. Even light cannot get out. We can't take a picture of a black hole directly. It's black. So how do we know it's there? We know it's there by studying the way stuff moves in its vicinity. Things orbiting close to it are going to go very fast. But you have to get very close to the hole in order to see that effect.
Scientists had theorized, but never proven, the existence of supermassive black holes billions of times the mass of our sun, until they used Hubble to look at the core of a galaxy called M87.
It was the superior spatial resolution of Hubble that was the key. In the galaxy M87, the gas on this side is coming towards you, and the gas on that side is going away from you. And we can measure the motions and calculate the mass of the black hole, 3 billion times the mass of our sun.
But how common are these giant black holes? Sandra Faber's team used Hubble to measure the speeds of stars orbiting around the center of other galaxies and discovered something remarkable.
We accumulated measurements of stellar speeds in, I would say, 24 galaxies. And in every one, we found evidence for a compact central mass.
Essentially, at the center of almost every galaxy, there is a supermassive black hole. There is some regulating mechanism here that makes the black hole and the bulge of stars around it grow together. So it is a chicken and egg problem in the sense that did the galaxy form first and then a black hole grew inside it, or did the black hole kind of seed the formation of the galaxy? And we're actually not sure what the answer to that is.
The precise relationship between supermassive black holes and galaxies remains a mystery. It's just one of the countless questions and profound discoveries generated by Hubble over its 25-year history. And its continued success is a testament to the humans who have kept it going.
We want you to use your best judgment that the pitching array will definitely clear the top of HST.
Astronauts have upgraded the telescope on 5 different missions since its launch.
Hubble has arrived on board Atlantis. Okay, here we go.
The last visit to Hubble was in 2009. Astronauts needed to replace the wide-field camera and install and repair spectrographs that could help peer into black holes and analyze the atmospheres of distant planets. As on past missions, ingenuity saves the day.
That handrail is obstructing the attachment of the fastener capture plate.
Astronaut Mike Massimino can't remove a handrail blocking his access to Hubble.
We couldn't get inside the thing to do the repair. And I just felt terrible. This is going to be my contribution to astronomy, which is killing our opportunity to be able to analyze the atmospheres of planets.
That darn handrail.
And I thought we were sunk, because I did not see any way we were going to fix this thing.
And then engineers come up with a radical idea. Break off the handle. It's a risky approach.
By yanking that thing off, by definition, we're going to have little shards of metal flying. So I put a lot of tape on that handrail and made sure that, you know, none of that stuff would get out.
Houston, you ready for this?
Yeah, we're ready.
Okay, Mass, you have a go.
Here we go.
Disposal bag, please. The handrail was out of the way. It wasn't going to be a problem anymore. I felt really happy that we got the job done and that we were leaving Hubble in good shape.
Hubble is working right now, probably the best it has ever worked. It produces discoveries every day.
The new instruments have allowed us to look deeper into the universe, revealing even more detail than before. This recent image of the Andromeda Galaxy is the highest resolution Hubble photo ever taken. More than 60,000 light-years across, it shows more than 100 million stars. And just this past year, a spectrograph installed on Massimino's mission analyzed the light filtering through the atmosphere of a planet 729 trillion miles from our own, and found water.
We absolutely couldn't have done this work without Hubble.
It's a remarkable contribution for a 25-year-old machine.
Every one of the science instruments were eventually replaced. You don't have any of the original ones left. And that's why it's still doing its job 25 years later. We don't warranty the labor. I'm not sure about the parts. You got to check with NASA. But I think it's going to be going for a long time.
But with the space shuttle decommissioned in 2011, there's no way to reach Hubble. And the telescope's days are numbered.
And John, this is like spacewalk number 714? Six. Okay, great.
Astronaut John Grunsfeld visited Hubble 3 times, more than anyone else, and was the last human to touch the telescope in 2009.
We'd finished all of the work that we had planned, and I was in my spacesuit, getting ready to come back into the airlock, and gave Hubble, one last tap to say goodbye. And I just felt incredibly happy that we'd had this amazing ride. And I watched it disappear off into the distance. And I knew I would never see Hubble again. But we'd accomplished so much, it was just a matter of joy.
Scientists hope that Hubble will work for another decade. But with every orbit, it encounters slight drag from the Earth's atmosphere. The telescope will eventually fall from the sky, probably in the late 2030s. Most of Hubble will burn up, but the mirror will likely survive re-entry. So NASA may send up a robot with a small rocket to help guide it safely into the ocean.
One of the requirements for the mission that we flew in 2009 was to install an adapter on the bottom of the Hubble Space Telescope so that a future mission could dock with it so that at the end of Hubble's life, we could send it into the atmosphere so that it would re-enter over a known place on Earth.
But before Hubble deorbits, NASA is planning to launch an even larger telescope called the James Webb. It has a foldable mirror 3 times larger than Hubble's and will be sent to an orbit beyond the moon. But it will be hard to live up to the legacy of Hubble.
The Hubble Space Telescope is probably the most scientifically productive instrument in history. Before the Hubble was launched, we didn't actually know the age of the universe. The Hubble just sorted that question out, bang. We had never seen black holes before. After Hubble, we know that every single galaxy has a black hole. We knew that when stars finish their life scale, they form planetary nebulae. Hubble just cataloged every single type of planetary nebulae, and then it caught supernova, blowing up. We had no idea the universe was filled with dark energy. We didn't even know that was possible. We've seen into the depths where stars are formed. We can actually see the formation of planetary systems. We knew that theoretically. We can now see all of that stuff. Just tick off all of those discoveries, and our whole worldview has just changed.
The human desire is to find out who we are. Are we alone? Where did we come from? How did we get here? These questions probably will outlive all of us. But I think Hubble has been very important in making progress toward these answers.
This NOVA program is available on DVD. To order, visit shoppbs.org or call 1-800-PLAY-PBS. NOVA is also available for download on iTunes.